Good day, everybody. Day 423, I believe. We just threw some food in the fish pond here. Got a lot of activity going on. Minnows, these are bullhead minnows. Got, looks like cooter, yeah, it's cooter. A bunch of other. We got the algae eater out this morning. I saw a shrimp earlier. A bunch of shrimp were active yesterday. The plants are looking good this morning. Everything is starting to catch in and starting to grow. Starting to get that lime green growth. Some new shoots coming up. These were looking a little rough, but you know, still might make it. This one here, excuse me, this one here is probably not gonna make it. It's just too far gone. We'll probably remove this one. We've got a few more over here. They're looking good. This one is, I don't know. We've got mushroom popping up in there, but not looking too hot. This one's definitely not going to make it. Did not like the mushrooms, as you can see. But they all don't make it. That's why we plant a bunch of seeds, and the strong will survive. Look at this one here. This one's really starting to show. All of these look really good. The genetics on this group here, you can definitely tell, is pretty superior to some of the others. We're not going to reveal who the genetics are until we pick the ones that we want. We let them get a little bit bigger. We make sure that they're going to make it and that they're going to be healthy, and then we will reveal the genetics. And the reason for that is because I don't want to ruin anybody's reputation with this experiment going on I have here, because some plants like it, some plants just aren't going to thrive in it. And that's not a, it's a genetics thing, but you know, it's not the fault of the breeder by no means. Most people aren't growing in this situation. You know, they're growing in a in potted mix, you know, bag soil. This is bag soil in the middle, but I'm thinking by now it's probably mostly IMO 3, IMO 4, IMO 5. The mix like this what I have here. No perlite, no nothing. It's just sand, silt, clay, basically soil from around the property that we've turned into IMO. We've added biology to it. We've added fungus from the woods, and yeah, once we get this cycle going, the nutrient cycle is what I'm speaking of. Hopefully the biology will start to break down the sand, the silt, and the clay and bring those minerals and nutrients out of that sand, silt, and clay and feed the plants. That's how nature works. That's how the forest works. Well, somewhat works. That's the basic of it, the basis of it. It's very complicated. I'm no scientist, and I don't claim to be. I've just been learning as I go. And I've educated myself quite a bit on soil and how it works, just the basics of it. And really, it's all about carbon. You know, we want carbon in the soil. How do we get carbon? We get carbon from plants. Plants like these elephant ears here. So that solar panel there, that big solar panel, the reason it's here is because it's, look how big that elephant ear is. Now I like these plants because they have huge solar panels. And that solar panel is what's taking that light turning it into, well, we all know it's photosynthesizing, but we turn that light into sugars. But we also are capturing that light and forming carbon bonds inside that plant. Those carbon bonds are what we're looking for when it comes to, like I say, a chop and drop. So we can cut this off, and everything this plant has pulled up, all the carbon that it's stored in its cell, all this is, we can chop this up and drop it right back onto the soil. And everything this plant has pulled up and turned into food for itself, all the minerals and all the nutrients that are in this plant will then go right back into the soil and continue the life cycle. That's how it works. When we remove stuff like that, when humans come in and remove that vegetation, we take that mineral away. And yeah, that's basically what we're doing. We're stripping the topsoil off of our planet and destroying it, when we should be planting more plants to produce more carbon to push down into the soil. When we go plowing and tilling and digging, we release that carbon into the atmosphere, which is what they're trying to capture. And like I said, I'm no scientist. This is just basic stuff. The more you learn, the more you realize that everything's connected. You know, everything. I mean, the soil and our guts are basically working in the same principle method. We have to eat, we have to chew it up, we have to then send it down our system. Goes through all these different processes before it ends up in our bloodstream, and we can use it for food and energy. Plant's doing the same thing. It's taking, where's it getting the energy from? It's getting the energy from the sun, or in here in the lights. Turns that light into energy, pushes it down into the soil. The soil then turns around and mines for the plant, and then the plant uptakes what the biology has mined, and then the plant grows, the plant dies, it falls, feeds the biology, and so on and so on. And then we get humans and life and all kinds of things. Who knows? It took a long time. You know, billions of years. Like I said, I'm no scientist. This is a total experiment for me. Never done anything like this before. The whole premise of this was to solve a water issue and to have something to do actually in my grow room. But really the principle behind this is to maintain the water it takes to make the biology thrive. So we all know that when it rains, everything likes to pop up and gets that burst of nitrogen from the rain, because the rain is picking up nitrogen from the atmosphere as it's falling, and then when it hits the ground, it releases that nitrogen and plants can uptake it. That's why you get that nice green growth after all that, after a good rain or a good high pressure system that's pushing that moisture down into the ground. This is all about water and water retention. So how this works is that what I've done is lay the sand, silt, clay, and organic matter on top of the creek wall, and then lay the sand and silt without the organic matter in the center of the creek, because in nature, the center of the creek or stream is where the least amount of organic matter is, because it's being washed downstream. It'll end up in the ocean. What this is doing is that this is clean in the center, but I add organic matter as we come up the sides, just like this organic matter would be falling down as the centipedes and millipedes and worms all work underneath this. Their castings and what's left falls down into the creek. It gets into that sand, silt, and clay, it mixes, and then it wicks, it stays wet. It wicks water all the way up into the plant bed. And we do this in certain spots because at first I had it all the way around and it was too much moisture coming over the wall. So what I did to regulate this was just to remove it from the sides and only add it in certain places. And this gives me that wicking action that I need into my bed where my plants are. Same thing up here. You can see how it's being broken down and falling down on the edges of the creek. That's exactly what I want. That organic matter is giving life. It's giving plants like my bluebells here, or purple bell, excuse me, something to grab a hold to, and those roots get in there and start sucking those nutrients out of that soil. And that's what we want, because the more roots I get in this creek or around this creek, the more the cleaner it will be. The cleaner the creek will be. So roots along this creek bed are what is actually going to help me reduce the nitrates, nitrites, all the different basically the shit that's coming out of the pond that's feeding it, the overload of it. There's no filter in the pond. There's no filter in this whole system. The creek is the filter. This is going to take time for these roots to get into that creek and start to really filter the water like I need it to. So I do expect, the algae, I expect some high nitrates in the pond. Maybe my ammonia may go a little high. My sulfates might be a little high in the water. All these things might be a little high at first, but they will balance themselves out as long as I don't go messing with a whole lot of stuff. So as long as I don't go adding anything to the water, like, just any type of chemical, I'm just going to leave it alone. That's the key to this, is just leaving it alone, letting it do its thing. All I have to do is steward it. So basically I'm just here to manage, make sure things don't get out of hand. Like, so when this thing, like when the algae starts to build up, I'll just come in, and pull some of it out and lay it over here. And over here, this is where the mites will come in and eat. Check them out. Now most people would freak out if they saw mites like that. I'm not freaked out because they're not on my plants and they're doing their job, and they're not a pest. They're eating the algae and pooping it out, which is exactly what I want. So as long as I have, excuse me, I got hair in my mouth. As long as I have enough food for these little guys, for the smallest of smalls in my in this system, they won't attack my plants. They have too many other things to do than to worry about my cannabis plant or any other plants in here, because they have plenty of food down here in the soil. So there's no reason, if the soil is balanced properly, if the soil is right, it has the right predators and prey. So the predators are preying on the prey, and the prey are in there trying to find whatever it is, the green that they're eating. So it's the cycle of life. We're just trying to get all of it in there. So the more diversity I have in species, from all the way down to the microbiology, the microbes, all the way up to the arthropods, the protozoa, all those things in the soil food web are all coming up till they get to me. So we're going from the tiniest of tiny. They need food, then the next thing needs food, and all up through succession. So all the way up to the top of the food chain. That's how this works. So everything is eating and pooping, living and dying. In the top 4 inches of this soil, this is where all the action takes place. Everything is living and dying, eating and pooping. And that's the cycle. As long as everything keeps eating and pooping and we don't get too much of one thing to take over, everything will stay in balance. But death and destruction must happen in order for balance to take place. So things have to die in order for things to live. That's how it works. I'm sure we've all seen Animal Planet. But it also works the same in the soil as well, on top of the soil. In the soil, there's a web, there's a food web, there's a line of succession that basically you have the small guy, who's eating the smallest bacteria or fungi, all the way up to the worms that are eating all of that. And the worm is eating basically dead microbes and bacteria and fungi and all that different things, and it's pooping out fertilizer for the. That's why worm castings are primo, probably one of the best, other than what I think fish. I like fish crap, but worm crap or castings is just as good. Tons of biology in it. Well, that's a little walk around today. Little layman's terms. I'm learning as I go. So as I learn, I'm just trying to repeat what I learn and hear from professionals. So I am not a professional. Don't claim to be one. This is just something I built to try and help myself and others understand how nature actually works. And we can actually grow really, really good cannabis and good food with no inputs, with no, byproducts, no human intervention. It just needs the right atmosphere and the right biology, and it needs to be in a place where all of it can come together. So that sand, silt, clay, organic matter, we got water, we've got food, we've got the whole 9 yards basically in one ecosystem. And the hope is that everything will balance itself out. The plants will thrive. I'll just be able to cut these plants when they're done and pop new ones in like I just did, and not have to do anything but maybe a foliar feed here and there. No amendments, just the IMO 3 topping off when we get done with the run to top off what these plants have taken. Chop and drop as we go. So you get the green from the chop and drop, then you get the brown from the IMO. Green, brown, green, brown. That equals compost. You add the water to it, you add a little bit of fish biology to it, and we're off to the races. I appreciate everybody watching today, and we shall see you tomorrow. Cooter, there's Cooter right there. He says bye. See you, Cooter. All right, y'all have a great day.